Hi, calculus scholars. We're going to get started by kind of looking at particle motions with equations. And we're going to kind of look at some level ones and some level twos. Level ones kind of just involve the computations of derivatives and finding things like the critical points or finding out what the velocity is at a certain instant. And then level twos kind of involve more, like sign chart type of analysis. So we're going to kind of do a few examples of each. So this is example one. So it says that a particle moves along the x-axis, and all of them have the assumption that we always have positive time. So time is always positive, so we don't have negative time. And we have to find when this particle, so we have a velocity function when the particle is at rest. So this means that v of t equals to 0. Fortunately, we are given the equation of velocity. And I would just pull out a 3 immediately. And you want to factor this. With like the ACB chart, I'm just going to kind of like tell you what I got after I factored. So I got, when I did this, I got t minus 5 and t minus 3. So that gets me at positive 15 and a minus 8. So I get t equals 5 and t equals 3 for my final answer. So at that point in time, so at 3 and 5 seconds, the particle is at rest. All right, example 2. This gives us a position function, x of t. So, and we have the same assumption that there's no negative time. Determine if the particle is moving to the right or left at t equals to 4. So what I'm going to do here is I'm going to do x prime of t. So this is going to give me our velocity. So that's going to be minus 3t squared plus 16t minus 20. And what we're kind of going to do here is we're going to actually do v of 4. So I'm just going to plug in 4 into my velocity. And I really suggest, for a good, efficient calculation, that you just use the handy Delta Math calculator for this. And like when we do v of 4, I'm just going to do negative 3 times 4 squared plus 16 times 4 minus 20, and I get negative 4. So I get v of 4 equals to negative 4, which is less than 0, obviously. So this means when we are left, when we are at a negative number, that we are moving to the left at t equals to 4, when we have that negative velocity that's going on. And we have enough information to kind of make that definitive answer. Now we're just going to click submit, and then we are good. Maybe one more at the level 1. That's going to get kind of like a new type of problem. Some of these, all right, so this is another type of problem that you're going to see. This says that a particle moves along the x-axis so that at time t is greater than or equal to 0, its velocity is given by v sub t. Determine if the particle is speeding up or slowing down at t equals to 5. So we are actually given v of t already. So if I want to find v of 5, I'm just going to go and enter 5 into my velocity function. And I really suggest that delta math calculator, so I'm going to get that out. I'm going to whip that out. And I got negative 3 times 5 squared minus 10 times 5 minus 32. And I get negative 7. And then if I want to find the acceleration, I'm just going to say that a of t equals to v prime of t. And that's going to be 6t minus 10. So a of 5 is equal to 6 times 5 minus 10. That one I really don't even think you need a calculator for. So that's equal to 20. So this means that the velocity and acceleration have opposite signs. And that means that we are kind of slowing down at that point. Now, I'm going to highlight something that's part of the explanation that I think is important when you see this type of problem. If the velocity and the acceleration have the same sign, it's speeding up. And if the velocity and the acceleration are having opposite signs, then they are slowing down. Okay, let's actually go and look at a level 2 now. All right, so level 2, basically level 2s are level 2s just because they kind of involve the use of a sign chart, so to speak. So we are given a position function. We still are working with the idea that there's no such thing as negative time. So I'm going to actually first take the velocity and then the acceleration. I think it's always good that you are kind of writing down which equation is what. So when I'm taking the first derivative, I'm finding the velocity. So that's going to be x prime of t. So that's going to be negative 8t cubed plus 96t. And then the acceleration of t is the second derivative. That's going to be negative 24 t squared plus 96. And now we're going to kind of just make a sign chart here. So I'm just going to kind of make a sign chart with a of t. And you want to find critical points and inflection points, depending on like which number of derivative. So actually, in this case, we're finding the inflection points since we're looking with the second derivative. So I'm just going to say negative 24 t squared plus 96 equals to 0. And I'm going to pull out a negative 24. So remember, if that first term is negative, we want to just pull that out with the number. So I have a negative 24 times t squared. And then 96 divided by negative 24 is going to be minus 4. So I got t squared minus 4 equals 0. That's going to be t squared is equal to 4. So that means that t is equal to plus or minus the square root of 4. And we're just going to do the plus version. So t equal to 2. And I'm going to maybe try plugging in 0 into my acceleration function. So if I plug in 0, This negative 24 stuff becomes 0, and I got like a plus 96. So that's a positive. And of course, 0 is the lowest t value that we are looking at. And then I'm going to try like a number bigger than 2 as well. So I'm just going to go to my calculator, and maybe I'll try a 3. So I'll do negative 24, and then I'm going to do 3 squared. And I'm going to add 96 to that. And that's a negative number. So what is kind of going on here is that my acceleration is going to be positive between 0 and 2. And that's my final answer. So really, level 2s are just kind of like applications of sine charts. So I'm going to kind of give you mainly some level 1s and a few level 2s on the eyepiece. And then next time around, I'm going to kind of give you ones that are a little bit more graphical in nature, but I want you to kind of gain some confidence first in the equation ones. So with that, feel free to kind of look through solutions if you get them wrong. Look at the reasoning. You can even ask me or a classmate of yours to kind of talk out the problem with you as well.